Our farming systems in Australia really developed on the back of the use of superphosphate. We've always had superphosphate or some phosphorus source, DAP or MAP more recently, as part of our farming systems. And our soils, many soils are relatively depleted of phosphorus. Some soils have adequate phosphorus supplies. But in terms of a phosphorus program, because of the history of maybe 50 to 100 years of phosphorus application, a lot of our soils are at maintenance levels. By that what we mean is that the soil's got adequate phosphorus to supply a crop, but if you remove the phosphorus, say with the surveys we did of grain phosphorus concentrations, said that basically 2 to 4 kilograms of phosphorus will be removed for each tonne of grain. And so what that means is if you take 5 tonne of grain out, you're taking somewhere between 10 and 20 kilograms of phosphorus out the gate. So you can do that for a little while, but at some stage you'll need to address that depletion. You can't mine the soil of phosphorus forever. Different soils have the capacity to bind and fix phosphorus to different degrees. So the ironstone soils, acid soils tend to capture and hold phosphorus more strongly than a lighter textured or an alkaline soil. That shows up in a soil test as what's called the phosphorus buffering index, and it gives you an indication of how much phosphorus the soil wants to build its background chemistry compared to what the crop might need to have available. If we go back and think about the 4 R's for phosphorus, source, rate, time, place, probably the big change has been the phosphorus source that we've seen. You know, again, back in the 80s, that was pre-DAP and MAP use. And big change came in with the introduction of those two high analysis or compound fertilisers, which had twice the amount of phosphorus, 2.5 times the amount of phosphorus that a superphosphate had. Meant you could only needed to cut half or 1/4 the amount of fertiliser around to get the same phosphorus rate on your paddock. A great strategy. It also meant differences in the distribution of phosphorus in the granules in the seed row, and that has now evolved into thinking about fluid fertilisers, fluid phosphorus sources that in fact have a very even distribution in the seed row. But I think the phosphorus story really is evolving all the time. Maybe new products come along, adjuvants available to phosphorus, co-granulation of sulphur, zinc and phosphorus in some products really have been good adaptations. Compound products such as high sulphur MAP or high sulphur DAP with zinc have that benefit of having the nutrition in the one granule consistently supplied to the crop, accessible to the roots and in the seed row. And that's been, again, something that's important. We did some work in association with the Victorian Department of Primary Industries at the time, looking at placement of phosphorus and nitrogen, and found that roots actually responded differently for the presence of nitrogen and phosphorus. Roots would chase nitrogen down because nitrogen's mobile, but they would cluster around a phosphorus granule. So if you put the two together in a compound fertiliser, a DAP or an MAP, you can get the benefit of that enhanced root growth, and then the roots can elongate as the nitrogen moves away.